if E equals to, that is electric field, 4ux minus 3uy plus 5uz in the neighborhood of a point 6, 2, minus 3, the incremental work done in moving 5 coulomb charge a distance of 2 meters in the direction of ux plus uy plus uz is. We know that work done is nothing but force into distance traveled here, which is nothing but minus QE into dt, there is distance traveled. So minus 5 4 into ux minus 3uy plus 5uz in the direction of this one. So we have to find out the unit vector in that particular direction, ux plus uy plus uz divided by root 3 2. So minus 20ux plus 15uy minus 25uz and 2 by root 3 ux uy uz. Here minus 20 plus 15 minus 25 to root 3. So minus 45 plus 15 to root 3, that is 30 to root 3 is equals to minus 34.64 joules. Hence option C is correct.
Following control scheme is implemented in phase control converters to improve power factor. Now what is phase control converters? We will vary phase angle such that there will be a change in relationship in voltage and currents. Okay, generally we will use this phase angle control, whereas remaining all controls are used in inverters. Okay, only one control, that is phase angle control, is used in rectifiers, or you can say phase controlled converters. So option B is the correct answer.
Integral of sin x plus cos x divided by under root 1 plus sin 2x dx equals to, here sin x plus cos x divided by sin x plus cos x whole square under root dx, which is equals to x. Hence option B is correct.
Given that out of one call out of 15 between 2 p.m. and 4 p.m. of week are busy, and we have to find the probability that exactly 2 calls will be busy out of 6 randomly selected calls. Now, let us take P as the probability that a telephone call is busy. Then Q will be nothing but probability that telephone call is not busy. It's ringing. Now P is given as 1 out of 15. 1 call out of 15 are busy, so P will be 1 by 15. So correspondingly Q will be 14 by 15. And we need exactly 2 calls. That means we have to find P of x is equals to 2 out of 6 calls. So the value of n is nothing but 6. So the formula is NCR into x to the power of P to the power of x, R into y to the power of n minus R. That is equals to n. N is nothing but 6 here. C, and we need exactly 2 calls, that is 2. And P is nothing but busy, 1 by 15. Raised to the power of R, that is square, into y. Value of y is 14 by 15. And this will be 4. If we simplify this, the value will be 0.0505, which is nothing but option
The instrument has a resistance of 3 ohms and reads 150 milliamperes. Okay, we have a moving coil instrument. Okay, this instrument is having 3 ohms resistance and full scale deflection is 150 milliamps. Now the resistance is needed to enable it to be used as voltmeter reading up to 15 volts is. Okay, that means to increase the rating of this one, what we have to do for voltmeters is we have to connect one resistance. Okay, now this is the total voltage applied across this one. Okay, the resistance needed, let us take it as this one as R. Okay, this R is equal to, what is the voltage by current rating here? 15 volts divided by current value is 15 into 10 power minus 3. Okay, this R plus, what is the meter resistance here? 3 ohms. So what is R value here? 15 by 150 milli, that is equal to 100 minus 3, which is equal to 97 ohms is required. So option D is the correct answer. 240 volts DC 1150 rpm shunt motor is operating at rated conditions. Determine the reduction in shunt field flux to raise the speed to 1800 rpm. Okay, we know that this relation N is inversely proportional to flux. As flux is decreased, speed is increased. Okay, speed is increased from 1150 rpm to 1800 rpm. Okay, if you decrease the flux, we have to calculate what is the decrease in the flux, assuming that the shaft load is adjusted to maintain rated armature current. Okay, armature current is given as constant. Okay, now what is back EMF? VB is equal to V minus IA RA in shunt motors. Okay, in shunt motors we can operate two types of speed controls. One is armature control, that is armature voltage control. Another one is flux control. Okay, now he has used this second method, that is flux control method. Okay, now what is EB2 by EB1 here? EB2 by EB1 is phi2 into N2 by phi1 into N1. I can write the relation from this equation. Okay, phi1 into N1. Now from this we have to calculate phi2 in terms of phi1. Okay, so phi2 is equal to phi times of N, phi1 times of N2 by N1. Okay, now what is the N2 by N1 here? N2 by N1 is given as 1800 divided by 1150 into phi1. So phi2 is around. Okay, how we got this relationship actually? Let us see now this one. Okay, here IA is maintained constant, so EB is also maintained constant. So EB2 is equal to EB1. We can cancel these two. So I can write from this phi2 into N2 is equal to phi1 into N1. Okay, so from this I can write phi2 is equal to phi1 times of N1 by N2. Now what is this phi1? Phi1 into N1 value is 1150 rpm divided by 1800 rpm. You will get phi2 as 0.639. Now what is the reduction in flux? Phi2 is equal to 0.639 times of phi1. That means reduction in flux by 36.1%. So option A is the correct answer.